So in this lecture, we are going to talk about controlled access to the medium, wireless channel quality and bitrate, and the capture effect. So let's talk about channel quality and transmission rate. So what is the transmission rate and what does it depend upon? So transmission rate depends upon the channel quality and the technology that is used for wireless communication. As an example, when we look at different Wi-Fi standards, such as those supporting IEEE standard of 802.11b, A, G, N, they support very different bit rates, and it ranges from 1 megabits per second to 150 megabits per second. Secondly, what we find is that if the higher is the quality of the channel, that means the better the signal to noise ratio, less obstruction in the environment, less multipath, the better would be the transmission rate. However, if you look at from the perspective of, let's say, a Wi-Fi access point, it has to support devices which might have very different channel rate as well as underlying technology that they're using. So they might be using two different Wi-Fi standards. A question that we might ask is that what is the impact of this heterogeneity on the average transmission rate that can be supported on the wireless medium? So let's start by asking what is an average transmission rate. It is the number of packets or data that is sent per second. So in a standard CSMA CA protocol, the node sends same number of packets on an average. Let's say now let's consider the case that you have X number of nodes with two different data rate. So we talk about data rate of 10 megabits per second and 150 megabit per second. What would be their impact on an average transmission rate? What we find is that the average transmission rate drops significantly when the devices use different data rates. The system is fair as it allows the similar number of packets, but the channel utilization suffers. Hence, if a different notion of fairness may be required for us to be better able to use the spectrum. As an example, we may consider allocating each node the same transmission duration. So that might be one such a metric. So finally, let's talk about another interesting aspect. So we have talked about again and again in the course that we would want to avoid collisions because they can cause packets to be corrupted and then they would have to be retransmitted. But many collisions do not always lead to loss of packet. What does it mean? For example, if a receiver hears from two radio stations or two wireless stations, and one signal from this station is much stronger than the other, what happens is that the receiver can receive the stronger signal even in the presence of this weaker signal from another station, and this is called capture effect. And capture effect plays a very important role in wireless networks, and in fact capture effect has been used to also develop highly efficient protocols for low power wireless networks. So next, let's talk about controlled access to the wireless medium. So controlled access protocols are a class of medium access protocols where wireless nodes or stations coordinate with each other to determine which station has the right to transmit right now. A station cannot transmit unless it receives authorization from other stations in the network that it is allowed to transmit. And these class of protocols or controlled access protocol reduce collision, control network congestion, and ensure that all the stations have a fair chance to access the shared resource, which is the wireless medium. So controlled access protocols often involve a specific process or a mechanism for deciding which station will transmit next, taking into consideration factors such as the priority, waiting time, or there could be other metrics that have been established. So we are briefly going to look at three different such control access medium access control methods. These are reservation, polling, and token passing. So reservation-based access methods are a class of medium access control protocols in which stations are required to reserve transmission slots before sending the data. And this approach helps reduce collision and improves the network efficiency, especially in scenarios where heavy or bursty traffic is present. So what happens in a reservation-based systems that you have special slots that where different nodes can try to contend for medium, and then they are assigned the data slots where they could actually communicate. So typically the time is divided into these reservation and data slot. And these reservation frames precede the data slot, which is then the reservation slots are used to figure out who will get access to these data slots. So as you can see, and sort of like it's intuitive as well to understand that the system is going to be much more efficient if there are many data frames that are sent after reservation, because reservation slots don't send in the reservation slot, you're not sending a lot of information. You're trying to sort of figure out who will get access to the data slot. So in a way, the data slot is where the data transmission happens, and the more the data slot and the more the utilization of data slot, the better would be the utilization of the channel. And these reservation contention slot can repeat, and then you will have a different number of data slot depending upon how much traffic needs to be sent. So this is actually one way of mediating control of the shared medium, and this is called reservation access method. So there is a second method which is called polling, and polling based medium access control mechanism typically has one primary or master station and a number of secondary stations. And the primary station is responsible for coordinating the communication with the number of secondary stations in the network. And for example, if you could have a mode of select. So let's say we have a case where we have a primary station and two secondary stations A and B. So the primary node sends a select message to the node B, and the node B says that acknowledge that it has received the select message and that it's free to transmit a message. And then the primary node sends the data message to the node B, which then finally sends an acknowledgement that I have received the data packet from the primary node. So this is a select way of, and it's polling. This way of sort of like mediating access to the medium is also called polling. Then what if one of the terminals or the sort of like end nodes would want to send a message to the primary node? The way it works is that, again, because it's based on the primary node initiating communication, it sends a poll message. For example, it sends to the device A, and device A says, no, I don't want to sort of like send any message to you. So it sends a negative acknowledgement message. Then the primary node sends a poll message again to the node B, and it sends a negative data back because it had some data that it could transmit. And then the primary node sends acknowledgement to the node to say that, okay, I've received the data successfully. So as you can see in this method, the access to the medium and sort of like the interaction is dictated by this primary node. So finally, let's discuss the third method for mediating access, and this is called token passing. Token passing is a medium access control mechanism where a unique token is circulated among the nodes in the network. The token grants permission to transmit data. So any node that holds a token has the permission to transmit. And the protocols that are implemented ensure that only one node can have access to the token at one time in the network. And this allows you to avoid collision, and there can be different topology on how the token is distributed among the different nodes in the network. So with this, we come to an end of this particular lecture.